What's up, guys? This is Physics 2 Lab 1 Charge Tape. I'm Mike Gonzalez, and I'll take you through it real fast. So, the introduction, I'm going to study the charge piece of tapes and estimate the excess charge in each tape. Fundamental principles include electrostatic attraction equations for electrostatic forces. So, the method of the experiment is to cut 3 strips of 20 centimeter clear tape. You stick one down. I'll show you in a second. Then you take another strip that acts as the base, and then you rip the two pieces of tape apart to charge the other tape. Then you suspend one in the air and observe how it interacts with another charged tape. So we're supposed to find out what the charge is and how many electrons are lost. Find that the charge of tape is positive at 1.8 by 10 to the negative 8 coulombs, and the electrons lost were reported to be about 8.7 by 10 to the 10. I'll show you more about that in a second too. So the physics principles and equations that we used were, first of all, Coulomb's law, which is just the force of the electrostatic attraction or repulsion is K constant times the charge of each divided by the distance between them, squared, inverse square law, of course. And then there's equilibrium, just saying that the force of the electrostatic attraction overcame the force of gravity or balanced it out, so they should be equal at some point. Gravity equals F equals mg, of course. And then the excess tape is just the charge of the tape divided by the charge of the electrons to see the how much charge is left there, basically. So it's pretty easy. So for experimental design and assumptions, we assumed that the tapes were the exact same dimensions, that they had the same charge. The charged tapes could be treated like point charges, that the charge was spread evenly across the tape. The tapes were held perfectly parallel to one another to avoid any vectors that were kind of weird, and then there were no interference from our hands which were touching them. So some pretty big assumptions here. Here's the design portion. The tape length was 0.2 meters. The tape width was 0.02 meters. The tape area was just, width times length. So there you go, 3.8 by 10 to the negative 3 meters. The tape mass was given as 2 times 10 to the negative 4 kilograms, and the flow distance was 0.03. So here's the setup, as I'm sure you're familiar with. Here's some pictures of the setup. So this is showing that, looks like the tape's repelling this one, so they must both be positive. Or they both have the same charge. And then we figured out later with the calculations that it was positive. This is just a brief showing of how the charge was created. Anyways, some calculations. So first we did force of gravity equals electrostatic attraction or repulsion, so equals mg. So then we can calculate the first gravity. So we calculate gravity, equate it to the force of electrostatic attraction or repulsion. Okay, so we figured that out. And it does repel, so we know that they're like charges. Then we can use this electrostatic part right here. Here, K is already known, D is already known, so now we can calculate for Q. We solve for Q, and we get 1.4 times 10 to the negative 8 coulombs. Then for excess electrons, we can just take the number of electrons total, the charge, and then divide by the charge of an electron, and we can find out how many electrons are lost. Then we can find the atoms on the surface, 3.8 times 10 to the negative 3 divided by the number of atoms that should be there, and we find this is about our number of atoms that's on the piece of tape. So then we can find the charge per atom, and then we can get our fraction, but that's not really important. What's really important is this force, the charge, and then the amount of electrons that are lost. All right, so lab pictures. So here's the computational model. We just plug in G, M, force of gravity, and then distance. Here's tape 1, tape 2, both color blue, whatever, it doesn't really matter. But we just use the code from lab 0, and you can see the charge given as 1.4 times 10 to the negative 8, which is pretty close to what we were getting from over here, 1.4 times 10 to the negative 8. So calculation matches the computational model, all great. Some possible source of error was like the loss of charge from handling the tape. Tape is not actually a line or point charge, so assuming that can cause some error. We also don't know about the diffusibility of the electrons across the tape membranes. The tape also might not be secured or entirely parallel to the other strand. And of course, the poorly charged tape via human error in charging. Finally, the discussion. What if the electrons were positive and protons were negative? Well, the observation would remain unchanged. Either way, both are going to be the same charge, and like always repels like. So it doesn't really matter. We would have seen the same thing. Why is it important to handle the charged tapes as little as possible? Well, the electrons can move from our hands or anything that touches it, really. That gets near the charged tape. So when electrons flow in there, neutralizes the positive charge and lessens the force of the repel. Conclusion, computational model is correct. The charged tapes can be treated as point charges if handled properly. Thank you.